All right, so like I said, this is 9.5 properties of logarithmic functions. And y'all, here's the thing. Since logarithms are really exponents, the properties are really similar to the properties of exponents. So there's four we're going to look at. First one is the product rule of logs. So remember when you multiplied variables, you added the exponents. So the product rule of logarithm says that if you got a log base a, m times n, we can rewrite that as the sum of the logs. So we'll have a log base a m plus a log base a of n. So we write the product of a log as the sum of the logs of the factors. So the second one, all right, y'all, let me let one in real quick. Second property is called the power rule of logarithms. So this one is really similar to the power rule of exponents that said when you had an exponent raised to an exponent, you multiplied the exponents. So y'all, this says that log base a m raised to the p. So you got basically an exponent raised to an exponent. We write that as p times the log a of m. So basically, all they're doing with the power rule is they're bringing the exponent down to the front and rewriting it as a product. All right, the third property is called the quotient rule of logs. And this is similar to the quotient rule for when you're dividing variables with exponents. When you divided variables with exponents, you subtracted the exponents. So this quotient rule says if I got the log base a of m divided by n, I can rewrite that as a difference of the logs. Log base a of m minus the log base a of n. So I rewrite a product as the sum of logs. The power rule tells me to bring that exponent down and write it as a product. The quotient rule tells me to rewrite a quotient as the difference of the logs. And then y'all, the last one, and this one mainly deals with simplifying, but this is the log of a base to a power. And we had some examples in 9.4 doing this. So this says that any log base a with a result of a to the x. Remember, when you had this situation, if the base matched that result raised to an exponent, the answer was always that exponent. And the reason why, if you brought the x down and rewrote it as a product, you would have x times log base a of a. Well, remember, the log base a of a part would equal 1. So you got 1 times x, which in the long run gives us that x. So y'all, these examples, the first 6 examples go over the 3 different properties. And then when we start getting toward problem 7 and so, we'll see some examples where we got to use this log of a base to a power. So for these first examples, and they're going to give us 2 problems of each to start out with, one using logs and one using ln, okay? So these first 2, they want me to express as a sum of logarithms. Well, if I want to express them as a sum, that means they're going to give me a product and I'm going to rewrite them as a sum. So for my first one, I got log base 22 of 22 times 484. So my product is the factor 22 times the factor 484. So to rewrite it as a sum, I'm basically distributing that log base 22 to both factors. So I have a log base 22 of 22, which was my first factor, plus that log base 22 of my second factor, which is the 484. All right, so we've got it written as a sum, so we're done. So y'all, the second one, they use the ln. They're doing the ln of b times c. So all we got to do, remember, is distribute, instead of a log through the factors, we're going to distribute the ln through the factors and rewrite it as a sum. So that'll give me an ln of b plus the ln, plus the ln of c. So let me write that better. That's the ln of b plus the ln of c. So you're just separating the factors using the addition, okay? All right, so for the next few examples, these next 2, they want us to express as a product. So if they want me to express it as a product, they're using the power rule, which means we're just going to bring the exponents down out front and rewrite it as a product. So for number 3, they got log base 10 of x to the 15th. So rewriting that as a product, we take this exponent 15, bring it down to the front, so we get 15 times the log base 10 of x. Well, they're not too bad. Just keep up with these little properties we got going on. So now the ln. So this one is the ln of the 4th root of a 6. So the first thing I got to do is rewrite that radical as a fractional exponent. So let me recall y'all on that. We had one the other day, but I'm going to give y'all the property again. So to rewrite a radical as a fractional exponent, you bring out the base, which is the a. And since this is a root, like a square root or a cube root, you always put a 1 on top, and then whatever that number is goes to the bottom. So this becomes a to the 1 over n, rewriting that radical. So y'all, that's what we're going to do to this 4th root of 6. We're going to bring out that base, which is a 6. And then we're going to write our fractional exponent. Since the index is a 4, we get a 1 on top, and the 4 goes to the bottom. So that this becomes an ln of 6 to the 1/4. Now, remember, all we got to do, bring that exponent 1/4 down to the front so that we get 1/4 ln of 6. So y'all have any questions over these yet? So they're not too bad. What they're getting us ready to do we're going to use these properties from 9.5 when we solve equations in 9.6. All right, so this one is going to deal with the quotient rule. So they want me to express as a difference of logarithms. So express as a difference, I'm going to take something being subtracted. And remember, it's always the top factor minus that bottom factor, okay? So y'all, for 5, we have log base R of D divided by 3. All right, so distribute the log base R to both factors and rewrite it as a difference. So you'll have log base R of D minus the log base R of 3. All right, now time for the one with the ln. ln of m divided by t. So do y'all want to try one? What would y'all get on this one if you rewrote it as a difference?
Not sure.
All righty, so remember, we're going to distribute the ln to both of these. So you're going to get an ln of m minus the bottom factor, which would be the ln of t. And y'all, that's all you're doing is remember that ln applies to both the top and the bottom. And if you notice on both of these, it's always that top minus what I got on that bottom, okay? All right, y'all, so now they're going to sort of combine some of these properties. They want me to rewrite these as sums or differences of logarithms. So 7, I got the ln parentheses x to the 4th, y to the 6th times a z. So since these 3 factors are being multiplied, I'm going to use my product rule, which says that I separate my products by adding. So you're going to distribute the ln to all 3 of these and use addition. So you got an ln of x to the 4th plus the ln of y to the 6th plus the ln of the z. So 3 factors, you're going to have 3 terms when you rewrite that. Now, to be totally simplified and done, there's one more step we got to do to this. And it involves this power rule. Notice the power rule says if I got log base A of m to an exponent p, I bring that p down front and rewrite it as a product. We all 2 of these got exponents. So these exponents got to be brought down to the front of those ln's and rewritten as products. So this one would give me 4 times ln of x plus this one bringing the 6 down gives me 6 times ln of y. And then at the end, this one only had a 1 for the exponent. So that's just going to stay a ln of a z. So to be totally simplified, those exponents got to be brought down, okay? All righty, so here comes, put a star by number 8, because this is a tricky one. They're giving me a log of a P4 Q5 over a M3 B9. So here's the thing. When you rewrite something like this, it's being divided. These two factors on top, the two factors on top will stay positive. So I'll be writing those with addition. These two factors on top, on bottom, I mean, the two factors on bottom, when we rewrite them, will be negative. So that's going back to my quotient rule. The stuff on bottom gets subtracted. The stuff on top stays positive. So the two factors on bottom will be negative when I rewrite these. So now we got to distribute that log to all four factors. So we'll have our log P4 on top plus our log Q5. Remember, the two factors on bottom got to be subtracted. So that'll be minus log M to the third minus log, what is that? B to the ninth. Oh, and y'all, I forgot something on this. This has a log base B on it. I messed that up. That was a log base B, so all these are log base B's. Okay, so make sure y'all write a little b on that. I didn't see that on my paper here. So log base b of P4 Q5 divided by M3B9. When I rewrote that, I got a log base b of P4 plus log base b of Q5 minus log base b of M to the third minus log base b of B to the ninth. So you know what I'm about to do? All these exponents are going to come down to the front. No, except for this one. I got a log base b of B to the ninth. Log base b of B to the ninth. That goes back to this fourth property up here that says if that log base matches that result to an exponent, well, I got a log base b that matches a B to the ninth. That means that that part equals a 9. So that equals the exponent, member. So that's using that fourth property up there. So when we rewrite this, bring the 4 down, you get 4 log B of P. Plus this one, bringing the 5 down, you get a 5 log B of Q minus 3 log B of M minus, remember this all turned into a 9. So at the end, all I got is my minus 9. So these look big because once you rewrite this, you're not getting rid of anything. You're just rewriting it and trying to simplify as you go by bringing all these exponents down to those fronts and simplifying any terms where those bases match those results, okay? All right, y'all, let's get ready. This one's going to be a LN. LN of 2 divided by 9 times x squared times a y. So there's only one factor on top. It's going to be positive when we rewrite this. The 3 factors on the bottom are the 9, the x, and the y. So make that a y. These 3 factors will be subtracted because they're on the bottom. So distribute the ln to all 4 factors. I'll have an ln of 2 on the top minus the ln of 9 minus the ln of x squared minus the ln of the y. So 3 factors on the bottom had to all be subtracted on that, okay? Oh, and y'all, what's my last move?
Would it be to bring the 2 down?
It's gonna be to bring that 2 down, so good job. So you got your ln of 2 minus the ln of 9 minus, what's that going to give us? 2 ln of x, and then minus your ln of y. And really, that's what you're going to look for on these is, do I have exponents that I got to bring down on the end, okay? All right, y'all, a log square root c to the 6 times d. So the first thing we need to do is rewrite this radical. Now remember, under that radical is the C6D. So y'all, when we rewrite the radical, the C6D needs to be in parentheses, because it's all under that radical, so everything has to be in parentheses. So what would I make that fractional exponent? So do y'all know what number's in this notch if there's not one shown?
Is it 1?
Well, we got a 1 on top. So if you got a calculator and it just has that radical on front of it, what's it doing?
Zero? Nothing?
Well, so think about it. If I put a 25 in there, what do y'all get out of that?
5.
Okay, so you took a square root, right?
Yes.
So if you just got a radical without a number, you're doing square roots, and it's like that number is a 2 sitting there, okay? So that this will give me a 1/2. So remember, if I don't have a number in that notch, you automatically assume that that's a 2, okay? All righty, so now all we did was get rid of the radical by writing it as a 1/2 exponent. So now what you do, you got to multiply this 1/2 by both these exponents inside here. And y'all, the d didn't have an exponent, so automatically it becomes a 1.
One half or 1.
Yeah, it's going to be a 1. And then when we multiply that, so now watch this. You got your log 6 times 1/2 gives me 6/2, which will give me 3. So the C will have a 3 on it. The D, 1 times 1/2 is just 1/2. So the D will stay to the 1/2 power. So you get rid of the radical by writing it as a fractional exponent, and then you multiply that by the exponents that are on your C and D. Y'all just remember that if the D didn't have an exponent, you got to treat it like a 1. All right, so now we got a product, so we're going to rewrite it as addition. Log C to the 3rd plus log D to the 1/2. So y'all, is that done?
No. Bring the 3 and the 1/2 down.
So I got to bring that 3 and that 1/2 down. Good job. So you get 3 log C plus 1/2 log D. Right, let me let one in real quick. Let's see. Oops, this is 11, my bad. On 11, I put another star by this, and this one's going to be sort of tricky like I had a while ago. This one is a log base C, and then it's got a 4th root of m to the 8 n 20 over C to the 7 A to the 5th. And y'all, just like I did here, my first step would be rewrite this radical. So I'm gonna bring down my log C. Now remember, that radical affects all 4 of these. So your M8, N20 over the C7A5, all that's got to be in parentheses. So my question is, what's the fractional exponent going to be?
One-fourth,
What did you just say? 1/4.
fourth.
There you go. So this one actually had the number there, so that automatically became that bottom number, okay? So remember what I did up here? I took the exponent, the fractional exponent, multiplied it by everything in the parentheses. We're going to take this 1/4 and multiply by all 4 of these exponents. So I got my log base C I'm going to bring down. So for my M, I got 8 times 1/4. That gives me 8/4, which will equal 2. So the M will have an exponent of 2. The N has a 20 times 1/4. Well, y'all, that'll equal 20 over 4, which gives me what, a 5. The C has an exponent 7. So 7 times 1/4, that's going to give us a 7 over 4. Cannot simplify that, so that's going to stay a 7 over 4. And then that A has a 5. 5 times 1/4 will give us 5/4. Can't do nothing to that, so that A will stay 5/4. And y'all, all we've done to this point was basically get rid of that radical. So notice, I got 4 factors. The 2 factors on top will be positive when we write it. The 2 factors on bottom will be rewritten as subtraction. So it's always, the tops are always positive, y'all, and the bottoms are always negative. So distribute your log C to all 4 of those. So you get a log C of M squared plus a log C of N to the 5th. Like we said, the stuff on bottom will now be subtracted. Log C of C to the 7/4 minus your log C of A to the 5/4. So really, there's 2 things I'm going to do to this. 3 of them I'm going to do one thing to, and then there's 1 I'm going to just totally do something else to. The one I'm doing something else to is this log base C of C to the 7/4. We got a log base C of C to the 7/4. Y'all, tell me what this will equal. So think about it. You got a log base that matches a result raised to an exponent. So every time that log base matches that result raised to an exponent, that answer was the exponent. So that means this part right here, minus log C of C to the 7/4, that's just going to be minus the 7/4. Everybody else, you're going to bring the exponents down out to the front. So watch when those bases match those results, okay? All right, so what we get now is a 2 log C of M plus a 5 log C of N minus, remember this part became 7/4, and then minus the log C, whoops, that would be a 5/4 log C of A. So bring my exponents down, simplify any terms that match that base and that result. So yeah, put your star on that because y'all, that's the tricky one right there, okay? And I've seen something like that on our test, okay? So Get used to playing with that. Convert that radical over to a fractional exponent, distribute, and then tops are positive, bottoms are negative. Oh, so now they're changing the game on us, y'all. So let me start on a new page. So y'all, now they want us to go the other way, and they want us to write as a single logarithm. And then it says simplify if possible. So these will start at number 12. So for 12, I got log base C of 67 plus log base C of 59. So since these are being added to go in reverse, I got to write this as a product. So bring down the log base C. My product will be the 67 times the 59. And y'all, my last step would be to what? Figure out what 67 times 59 gives me. So if I multiply 67 times 59, I get 3,953. So that's what they'll mean by simplify. This one I could actually multiply and come up with that product, okay? All right, y'all, so let me see here. We got log of 100 minus the log of 10. This one's being subtracted. So remember, subtraction we got when we had a quotient. The top's the positive part, the bottom will be the negative part. So bring out that log. The top will be the 100 divided by the bottom, which is the 10. Hey, y'all can go further with that, right? We know what 100 divided by 10 is. So 100 divided by 10 will equal 10. So let me ask you this, and y'all got a calculator. Can this log 10 go any further being simplified?
Is it 10?
Now remember what base is here. Remember, since there's not a base here, it's like a 10, right? So what did we get every time when that base matched that result?
Is it the 0 or 1?
Oh, how about we go with that 1? There you go. So anytime that base matches that result, you will get a 1 on that, okay? All right, y'all. So that's what they mean on that one. It'll say, it'll have you write the answer, then it'll say it simplifies down to the 1. All right, so now they're turning it up. 1/3 log C of X plus 5 log C of Y minus 4 log C of X. So since we're working in reverse on this one, y'all, our first step would be to bring the exponents up to the variables. Remember, my last step is usually to bring the exponents down, so that means going the other way. That's your first step. So y'all, this will be a log C of X to the 1/3 plus a log C of Y to the 5th minus a log C of X to the 4th. So bring the exponents up. Now, if they're positive, they're going to be on top of my fraction. The one that's being subtracted, that factor will be to the bottom. So break out that log C. Right on top, you got an X to the 1/3 times a Y to the 5th. On the bottom, we got an X to the 4th. And y'all, this is so close to being done, but we're not allowed to have X's on top and X's on the bottom. So what we do in this case is we're going to subtract the exponents. And we always subtract the smaller exponent from the larger. So this larger exponent is in the bottom. That means the answer will stay in the bottom for the X's. So I know I got my log C. The only thing on top is going to be the y to the fifth. So what we got to figure out is what 4 minus 1/3 will give us. So I'm subtracting exponents on the X's. So 4 minus 1/3, you can treat that like a 1 on the bottom. Common denominator will be a 3. So to turn the 4 over 1 into a 3, on bottom, I multiply top and bottom by 3. So that'll give me 12 over 3 minus 1 over 3. So that'll be something over 3. So what do we got? 12 minus 1 will leave us 11 over 3. So that means the X, its exponent now becomes the 11 over 3. And y'all, that's the trick on this one. You're going to have a fraction on top, no matter what. It'll be a 1/3, a 1/4, or something. And then you're going to have a bigger fraction, a bigger exponent on the bottom, possibly a 3, 4, or 5. You're going to have to subtract them to simplify that to the final answer. All right, 15 deals with the ln. ln of x to the 6th minus 3 times ln of the cube root of x to the 5th. Y'all, guess what? First thing I'm going to do is turn this radical into a fractional exponent. So now, check this out. When you got exponents on the variable, so say I got something like this. A with the exponent in a radical like this. To rewrite this one as a fractional exponent, the top is no longer a 1 because you got an exponent by the variable. So that means the top number becomes that exponent, and the bottom number of the fraction is still the index of the radical. See, before when we did this, we didn't have exponents here, so we automatically made it a 1. That's why I was getting 1 over whatever the radical was. So knowing that, this x will come out. What's that fractional exponent going to be?
Five thirds.
5/3. Good job. Now, this 3 has to come up. Remember, that's my first step. Bring that 3 up. So the 3 is going to multiply by the 5/3. And y'all, since there's a lot of fractions in this section, y'all can use them TI-83, 84s to do all this multiplying if you want to. But when you multiply 3 times 5/3, the 3's basically cancel, leaving me with my 5. So this gives me an ln of x to the 6th minus the ln of x to the 5th. So 3 times 5/3 left me with x to the 5th. So now these are being subtracted, so we rewrite it as a quotient. ln, the top is the positive part, the bottom will be the part being subtracted. And y'all, guess what? X's over X's, just like we had up here, X's over X's. This time you're top heavy, and you're still going to subtract exponents, but now the answer stays up top. So I got an x to the 6th over x to the 5. That's going to leave me an x to the 1st, or just the x. Now, if it would have been bigger on bottom, this would have been 1 over x. But since I was bigger on top, I just did 6 minus 5 to leave me with 1x. So notice they're hitting you with a few exponent rules in this section. They're wanting y'all to get used to, I'm subtracting here, and when we rewrote those earlier that were quotients, we subtracted, okay? So still following these rules on those exponents. All right, y'all, so we got 2 more. And this lesson will be done. And I will say this, the last 2 are going to test y'all's factoring. So the first one is ln x squared plus 10x plus 24 minus the ln of x plus 6. So nothing we can do inside the parentheses. So since this is being subtracted, we'll rewrite it as a quotient, the positive on top. The stuff being subtracted, the x plus 6, goes to the bottom. So now what we got to do is see if this will simplify. And the way you simplify fractions like this is by anything that's not factored, you got to factor it. So the bottom you can't do nothing to, but that top we can definitely factor. And the top's going to factor into 2 sets of parentheses all over that x plus 6. Now, if it's going to simplify, one of those 2 factors on top has to be an x plus 6. That's the only way I can cancel them out, okay? So we got an x squared, that'll be an x and an x. What would both these signs be? Well, y'all remember?
Positive 6 and 4.
So positive, yeah, because they're positive, both signs will be positive like the middle, and then factors that add up to 10 will be 6 and 4. All right, so now that means I can cancel out those x plus 6s that match up. So my final answer will be a ln of x plus 4. And y'all in math lab, that x plus 4 has to be in parentheses. Because remember that ln affects both of those, the x and the 4. So y'all 16, y'all going to have to factor y'all's top also, okay? Then 17 was the same thing using a log. Log of an x squared minus 5x minus 14 minus the log of x squared minus 4. So we can't do nothing in the parentheses, means we're going to rewrite this as a quotient because it's being subtracted. The top will be x squared minus 5x minus 14. The bottom will be x squared minus 4. So since both of these have x squareds, we got to factor that top and that bottom. All right, so on top you got an x squared, that's an x and an x. That last sign for 14 is negative, so you got unlike signs.
Negative 7, positive 2.
Negative 7, positive 2. Good job. So the larger factor always has that sign as the middle. All right, watch this. You got an x and an x down here. Last one's negative, so you got a positive and a negative.
2.
So there you go, 2 and a 2. So treat the middle of this one like a 0, and your final factor of the 4 that'll subtract and give you 0. But do we call this the difference of perfect squares? And it's always whatever the square root of that last number is that you're putting into these. Well, guess what? X plus 2's canceled out. Now, since I got a fraction left, I can actually write that as x minus 7 over x minus 2. I don't have to put parentheses around this one because MathLab knows that since it's a fraction, it's automatically, technically got parentheses around that top and bottom. Since that's my numerator and that's my denominator, okay? So 16 though, you gotta keep parentheses for that one. So y'all, that's 9-5, okay? Learn those 4 properties that I gave y'all in the beginning. These 4 properties, follow those to work through these questions. If they want you to write it as a sum, you're using the product rule. Express as a product, you're using the power rule. And then express as a difference, you're using that quotient rule, okay? So y'all, any questions? I'm gonna stop sharing that screen. So y'all realize we got 9-6 and 9-7 to do next week. We'll do one Monday and one Wednesday. Then you got your Thanksgiving break, and then we come back. We're going to review for test 4 and the final. So not much new knowledge left except for next week, okay? So y'all, do y'all have any questions?
Nope.
All right, so y'all hang on just one second. Let me make sure I got what 3, 7, 10 of y'all. 1, 2, 3, 4, 5, 6, 7. All right, I got everybody. So y'all, I will send this video out about 30 minutes or so, getting it uploaded. I'll send this out. So by Sunday night, you want to work up through 9-5. And if you haven't done test 3, you need to get that done by Sunday night, okay? All right, y'all, let me stop my recording then.